Good morning to every student. Once again, I welcome to all of you in the video lecture series through BISEC. First of all, congratulations to all of you for getting admission in Diploma Engineering and wish you all the best for making the bright career in engineering field. Now, our subject is Basic Engineering Drawing and topic is Geometrical Construction. In previous two sessions of geometrical construction, I have discussed geometrical constructions of line, geometrical construction of angle, then geometrical construction of arc and circle, geometrical construction of tangent. Then today we will see the geometrical constructions of polygon. In that we will include triangle, square, pentagon and hexagon, heptagon and octagon. Now this is the list of topics. Today we will see the topic 4, geometrical constructions. Myself R. Patel, lecturer in mechanical engineering, RC Technical Institute, Ahmedabad. Then this is the again teaching and examination scheme. Those who are new viewers, they can understand. Total 200 marks, 100 marks for theory, 100 marks for practical, and 2 head in each: progressive assessment, ESE, progressive assessment and ESE. This is our subject expert team. Myself R. Patel, convener, then Atul Shah, Professor Niyaz Mansoori, Professor Chirag Shah, Professor Nisha Pandya. This is our topic number 4, geometrical constructions. We will continue with this topic today. Now this is the content of topics: geometrical constructions related with line, then geometrical construction related with angle, then geometrical constructions related with polygon. In that we will include triangle, square, pentagon, hexagon. Then to draw the tangent, and geometrical constructions related with circles and arcs. Now this is the major learning outcome. After study of this chapter or topic, you will be able to draw polygons, circles, lines with different geometrical constraints and conditions. So this is the learning outcome after studying this chapter. Now introduction. For preparing technical drawing, number of simple geometrical constructions and engineering curves are frequently used. Engineering curve will be discussed in next topic number 5. In this topic, we shall deal with problem on geometrical construction based on simple theorem of plane geometry, which are essential for preparation of engineering drawing. In geometrical construction, different combination of 2D drawing entities with satisfying the given constraints and conditions are drawn in 2D plane geometry. So this is the basic objective of this topic. Now different drawing entities or different primitives of the geometrical constructions are point, line, angle, plane, arc, circle, polygon. These are the different entities, drawing entities. These are the different geometrical condition or constraints. One is parallel, lines that are having the equal distance with each other at each point along their length. It is called parallel line. This is also symbols of parallel line. Perpendicular, lines are at 90 degrees from one another. This is also symbol of perpendicular line. Then horizontal line. When parallel to horizon, then it is called horizontal line. Line is also parallel in horizontal projection plane and will appear true length. Vertical line. A line is vertical when it is perpendicular to horizon. So vertical line is perpendicular to horizontal line. This line will be parallel to front and profile plane also. Then tangent. Here there are two figures for tangent. One is tangent to the circle and another in figure B. Two circles are tangent to each other at common point of tangency. Then collinear. Lines that if projected at each other will become the same line. So it is called collinear. Coplanar. Two or more objects that sit in the same plane. Then it is called coplanar. Plane containing the entity is same. Fixed point. Point that has been forced to stay in one location in space. It is called fixed point. Equal. Two or more lines, arcs or circle that are given the same magnitude. If magnitude is equal, then they are said to be equal to each other. Concentric. Here there are two concentric circles. Circle and arc shares the same center point. In first figure, two circle is having the same center. In second figure, two arc is having the same center. Then coincidence, same point. When points that share the same location on the coordinate plane, then points are said to be coincident. Then other minor constraints are non-parallel, intersecting, bisecting, concurrent, less than and greater than. So these are the different geometrical constraints or condition. Now polygon is an plane figure bounded by straight sides. If polygon is having equal angle and equal side, all angle is equal, all sides is equal, then it can be inscribed in or circumscribed around the circle, and that polygon we can say as regular polygon. In first figure there is triangle inscribed in circle. In second figure, square is circumscribed around the circle. Third figure is of regular pentagon. Fourth figure is for regular hexagon, then for heptagon, then for octagon, then nonagon, decagon and dodecagon. So these are the different polygons that we will include here in geometrical construction. For regular polygon, the angle, outside angle of polygon is 360 divided by n, and a central angle as the center, included angle as the center is also same. An angle made internal angle of the polygon we can find by 180 minus 360 by n. So this is the formula for calculating the angle of any polygon. That depends upon number of side of the polygon n. Now we will see the geometrical constructions of polygon. First is triangle. Triangle is also special type of polygon having the three sides. Here we will see the geometrical constructions of equilateral triangle. Means all sides are equal. In first figure, we will construct equilateral triangle with the help of t-square and z-square. So first of all we can draw the line AB of the given length. Here we are knowing the length AB. So we can draw the line AB. Then at 60 degree with the help of 60 degree z-square we can make 60 degree at point B and 60 degree at point A, and both line will intersect at point C. So in this way we can construct the equilateral triangle. In second figure B, we are constructing equilateral triangle with the help of compass. So first of all, we are knowing the length of AB 60 mm, we can draw the line AB. Then taking A as center and 60 mm radius, draw the arc. And again taking center B and 60 mm radius, you draw another arc intersecting at same point C. You join AC and BC, then we will get the equilateral triangle ABC with the help of compass. Then here geometrical construction of equilateral triangle when we are knowing the altitudes. Here OC is the altitude and length of OC is 50 mm. So first of all we will draw the line PQ. On line PQ we will mark the point O on it. Draw a 50 mm long line OC which is perpendicular to line PQ at point O, and take the length equal to 50 mm. OC is 50 mm. Then at point C, with the help of 30 degree set square, you make 30 degree angle on both sides of OC at point C. Then this line will intersect line PQ at point A and B, and in this way we can get the equilateral triangle ABC having the given altitude OC is equal to 50 mm. Then special method of triangle when altitude is given. Here also we are knowing the altitude, means length PQ we are knowing, and we are doing geometrical construction with the aid of compass. We will use the compass here. So again you draw any line AB. On line AB you take point P anywhere. Then at P you make perpendicular to line AB. Then take the length of perpendicular PQ is equal to length of altitude that is given to us in the data. Then at point Q you draw one arc of any radius that will intersect altitude PQ at C. Then on this arc at both sides with the same radius you draw another two arcs which will intersect at point E and F. So arc CE is also making 60 degree, arc CF is also making 60 degree at point Q. So bisect these two arcs again and we can get the angle 30 degree on both sides of the altitude PQ by bisecting the arc EC and CF. How to bisect the arc, that I have explained in the previous session. So these two bisecting line will meet to line AB at point R and T, and in this way we can get the triangle RQT having the given altitude PQ. Special method of square when we are knowing the length of side. First of all we will draw with the help of compass. So this is the geometrical construction of square and with the help of compass. Here also we are knowing the length of side. So first of all you draw the length AB of given length. Then at point B you draw the perpendicular. How to draw perpendicular I have explained in previous session. Then you take length of BC is equal to length of the given side. At point C you take arc is equal to length of the side and you draw the arc. Again taking center A you draw same length intersecting the previous arc at point D. So we can join CD and AD, and in this way we will get the square ABCD with the help of compass having the given length of the side. Again we will draw the square with the help of set square. Here also we are knowing the length of side of the square. So first of all you draw line AB having the given length. Then at point B with the help of 45 degree set square you make 45-degree angle, and with the help of 90-degree set square you make 90-degree at point B. Again at point A, with 45-degree set square you make 45-degree with line AB, and 90-degree with 90-degree set square at point A. So these two lines will intersect at point D and C. You join C and D. So in this way we will get the square ABCD having the given length of side with the help of T square and set square. Here we have not used the compass. General method of polygon, when length of side we are knowing. So this is the general method. With this method we can draw any polygon. We can draw even triangle, square, pentagon, hexagon, heptagon. We can draw any polygon with this general method when we are knowing the length of side of the polygon. First of all, draw a line AB with A as center and radius AB. Draw a semicircle. Then divide this semicircle into equal parts as the number of side of the polygon. Here we want to draw heptagon. Then you divide the semicircle into 7 parts because heptagon is having the 7 side. Then you join A with part 2 and you bisect line A2 and AB that will intersect at point O. With the help of center O, you draw a circle passing from point A, B and 2. Then again on this circle, you cut the point arc by taking successively center B, and length is equal to length of the side. So we will get the point C, D, E, F. You join this all point in sequence on the circumference of the circle. Then we will get the required heptagon A, B, C, D, E, F, 2 and A. So in this way we can get any polygon. We can draw also triangle, square, pentagon, hexagon, heptagon and even octagon also. Then in figure B, so this is the circle method. In figure B, we are using the arc method. We are using the compass in figure B. Again, we are knowing the length of side of AB. Taking AB as radius, you draw semicircle. Then you divide semicircle into equal parts. Again, we want to draw heptagon. So we will divide this semicircle into 7 parts. Then join A with point 2. Then again here you join A with 6 and draw taking center B, and arc is equal to AB line that will cut extension line A6 at point C. Now taking again as center C and A5 extended line, you draw this arc of same radius that will give you the point D. In the same way, you extend the line A4 and with center D, you draw the arc with same radius that will give you the point E. And again, you extend the line A3 and with center E, you draw the arc of same radius that will give you the point F. You join all these points in sequence. So we will get the required heptagon A, B, C, D, E, F to A. So this is the arc method. We are using the compass for drawing the arc. So it is called arc method. Now this is alternate method, general method for polygon. when we are knowing the length of side. Here, first of all, you draw AB line of the given length. At B, you draw the perpendicular PB equal to AB. Then you join line PA, and also taking center B, you draw the arc PA. Then you draw the bisector of line AB that will intersect to the line AP and arc AP at point 4 and 6 respectively. You bisect line 4, 6, then you will get the point 5 at the center of 4, 6 line. Then taking the equal distance 5, 6, you get the point 7. Then again taking equal distance, you get point 8, point 9. And taking the center, here we want to draw the heptagon, so take the center 7. If you want to draw the pentagon, then you take center 5 and draw the circle passing from the point A and B. Here we will take the center 7 and we will draw the circle that will pass from point A and B. Then on this circle you cut the length equal to side of the polygon that we are knowing successively, and we will get the 7 point, and you join this point in sequence, then we will get the heptagon. This is the general method, because with help of this method we can draw also pentagon, square, heptagon. Only difference is that we will have to take different point. When you want to draw hexagon, then you take the center as 6 and draw the circle. We want to draw the octagon, then you take the center 8 and you draw the circle. So that is the difference. Now here in below figure there is minor difference. Here taking AB as a diameter, we are drawing the semicircle, and taking B as center and radius equal to AB, we are drawing the arc, and we are drawing the bisector of line AB that will meet to semicircle at point 6 and arc 4 and to the arc at point 6. And in the same way as we have explained in the previous figure, you can draw the polygon. So some part is different, but 60% is common method. So this is the alternate way how to get the point 4, 5, 6, 7, 8. Then method will remain same. Remaining method will remain same. Now again we will draw the pentagon with the help of special method. With this method we can draw only pentagon, and this method is called 3 circle method. Here we are knowing the length of side AB. So first of all you draw AB line, then taking A as center you draw the circle passing from point B. Then again taking center B and same radius equal to AB, draw another circle passing from point A. This will intersect, these two circles will intersect at point P and Q. You take center P and with same radius AB, you draw another circle which will intersect circle 1 at point R and circle 2 at point S. Now you join P with Q that will intersect the arc RS at point M. Then you join R with point M and extend the RM, so you will get point C at the intersection with the circle 2. In the same way you join S with M and extend the SM line which will intersect the circle 1 at point E. So we can join now B with C, A with E. Now taking E as center and radius equal to AB, you draw arc. Then taking center C and same radius, you draw another arc. intersecting at point D. So in this way we can draw the pentagon when we are knowing the length of side. This method is called three circle method because we are drawing the three circle in geometrical construction. So it is called three circle method. Then again special method for pentagon, that is called diagonal method. Here we are knowing the length AB. You bisect the AB and get point P. Then at point B you draw perpendicular BQ is equal to length AB. Then taking center P and radius equal to PQ, you draw arc QM. Then AM is the length of diagonal. AM is the length of diagonal. So taking center A and length equal to AM, you draw arc. Taking center B and radius equal to length AB, you draw another arc, and we will get the point C. Same way we can get the point E. Taking center B and length equal to diagonal AM, we can draw one arc. Taking center A and taking length of side AB, another arc, that will get the point E. You join A with E. Same way taking center A and length of diagonal AM, we can draw one arc, and center B and same length of diagonal, we draw another arc which will intersect at point D. We can join E with D, C with D, and we can get the required pentagon A, B, C, D, E. So this is the special method. By knowing getting the length of diagonal by geometrical construction, we can draw the pentagon. This is also special method, but it is called angle method. We are calculating the angle, internal angle 360 divided by 5, then we can get the internal angle 108 degree. So you draw the line AB of the given length 40 mm. Then at point B you draw the angle 108 degree with the help of protractor. Again at center A you draw the angle equal to 108 degree internal angle, and you draw A line having the length equal to AB. So we can get the point C and E. Then again you take center C and take radius equal to 40 mm and draw the arc. Again you take center E and same radius 40 mm, you draw another arc that will intersect at point D. So in this way you join ED and CD. So this is the special method. In this method we are calculating the internal angle by the formula, and then we are drawing the pentagon. Special method of hexagon. Here this is when we want to draw the hexagon, then we can draw the hexagon by drawing the circle of the radius equal to the length of side. Here length of side is 40 mm, so we can draw the 40 mm circle, radius circle, and you take same radius and draw the successive arc on the circle. Then this circle will be divided into 6 parts. So this is the special method by taking the circle having the radius equal to length of the side of the polygon. So in first figure we have drawn the circle having parallel sides vertical. In second figure we have drawn the hexagon when two parallel sides of the hexagon is horizontal. So where you are taking the initial point for drawing the arc on the circle, that will decide either to draw the vertical hexagon or horizontal hexagon. Here theme is we are taking the radius of the circle equal to the sides of the polygon of the hexagon. Special method of hexagon when length of side is given. Here also we are using the t-square and set square, and we are knowing the length of internal angle also. Here we are drawing the hexagon, so internal angle is 360 divided by 6, so internal angle is 120 degree. So first of all you draw the line AB of 40 mm length, then at point B with the help of protractor you draw two angles, one is 60 degree, another is 120 degree. Then at point E, A, you draw one line at angle 60 degree, another line at angle 120 degree. Then on this both 120 degree line, you cut the length equal to the 40 mm. So you will get point F and point C. Again, you take center F and 40 mm length arc, you cut and you get the point E. Again you take center C and length equal to side of 40 mm, you draw another arc, then you will get point also D. You join D with E, then you will get the required hexagon. So here we are knowing the length of side. With this method of 120 degree internal angle, we can draw only hexagon. So with the help of t-square, set square, and knowing the internal angle, we can draw the hexagon. Now this is the special method of octagon inscribed in square. Here ABCD is the square of the given size, and we want to draw inscribed octagon in this ABCD square. So first of all take center A and draw the arc passing from the center of the square O. Again take center C and draw with same arc, same radius, you draw the arc passing from the center O. Then you take center B and draw arc of same radius passing from point O, and take center D and with same arc you draw another arc passing from the center O. So in this way we are getting the all point on the side of the square, point 1, 2, 3, 4, 5, 6, 7 and 8. You join all these points in successive sequence, then we will get the octagon which is inscribed in the given square. Now this is the general method of polygon when we are knowing the size of the circle. Here we want to draw the polygon inscribed in circle. We are not knowing the size of the side, but we are knowing the size of the circle. So size of the circle is given and we want to draw the polygon inside this circle. So this is the general method. We can draw with this method any polygon. Now first of all you draw the circle of given diameter, then divide the diameter AB into 5 parts. Here we want to draw the pentagon, so you divide this diameter AB into 5 parts. Then you take center A and taking radius is equal to diameter AB, you draw one arc. Again center B and same radius AB, you draw another arc which will intersect with the previous arc at point P. You join point P with 2 and extend, so on the periphery of circle you will get the point C. You join A with C, so AC is the length of the pentagon. So once we have got the length of the side, then taking same length AC, you draw successive arc and get the point D, E and F, and you join this point in sequence, so you will get the required pentagon inscribed in the given circle. This is again general method for polygon. With the help of this method, you can draw even hexagon, heptagon, octagon also. You can draw also triangle and square also. Then special method of square. In first figure, here also square is inscribed in circle. This is the special method for square. You draw one given circle of the given diameter, then take vertical diameter, horizontal diameter, and you get 4 vertex. You join this 4 vertex, then you will get the required square inscribed in the circle. Here diameter of the circle will be equal to the length of diagonal of the square. In second figure, we are inscribing circle and subscribing the square. So here we are using the set square and T square. So again you draw one vertical diameter, horizontal diameter, then you draw the taking center at vertical diameter 45 degree angle which is tangent to the given circle. Then you take another vertices of the circle and you draw the tangent line at 45 degree. So we can draw all 4 lines which is tangent to the circle at 45 degree to the horizontal line. So we can get the square, required square, which is circumscribing the given circle. Again, this is the special method for pentagon, inscribed in a circle. Here we are knowing the diameter of the circle or size of the circle, and we want to draw the pentagon. This is the special method. So with the help of this method, we can draw pentagon only in the circle. So here, suppose 70 mm diameter is given of the circle. You draw 70 mm diameter circle with center O. Then you draw horizontal diameter AB, vertical diameter CD perpendicular to AB. Then you get center point of the AO, N. N is the center point of the AO. You bisect the AO and get the point N. Then taking center C and length equal to Cn, you draw the arc. So here we are taking Cn equal to Nm and we are getting the point M on the OB by taking Cn is equal to Nm. So here Cm is the required length of the pentagon. So taking Cm as required length of the pentagon, you take the successive point on the circumference. Taking initial point at C, you can get point 1, 2, 3 and 4 on the circumference of the circle, having the length is equal to Cm. So by this construction, we have find out the length of the Cm, which is the side of the pentagon, which can be inscribed in given circle. Again, this is the special method of hexagon, inscribed in circle. So here we are using the length T square and set square. So here we are knowing the circle and we want to inscribe the hexagon in the given circle. So first of all you draw the circle, then you draw horizontal diameter, vertical diameter of the circle. Then with the horizontal diameter you draw 30 angle line DC and 30 angle line AB with the help of T square. Then you get the point A, B, C, D and you join this all point in sequence. So you will get the hexagon. In second method, we have taken 60-degree angle. So you can draw the hexagon having the parallel line horizontal. In first figure, parallel lines are vertical. So in first figure, with the horizontal diameter, we are taking 30-degree angle. In second figure, with the horizontal diameter, we are taking the 60-degree angle. On the same way, we can draw the hexagon circumscribe around the circle with the help of t-square and set square. Special method of hexagon inscribed in circle. This is the special method. We can draw hexagon with this method only. Here we are knowing the size of the circle having the 40 mm diameter radius, 40 mm radius. You draw the circle. Then taking same radius and starting point A, you draw the successive arc of 40 mm. Then you will get the 6 point on the periphery of the circle. You join all these points in sequence. Then you will get the hexagon A, B, C, D, E, F. In second figure, this is the horizontal hexagon. In first figure, it is vertical hexagon. So initial point, we have drawn the diameter AD horizontal and take initial point on horizontal diameter. So you will get the horizontal hexagon by the same way. Now again, this is the special method of heptagon. We are knowing the size of the circle. We want to draw the hexagon, heptagon inscribed in the circle. So with the help of geometric construction, we will find out here the length of side. We are knowing the size of the circle. By the geometrical construction, we will find out the length of the heptagon, and then we can draw the heptagon inscribed in circle. So we will do the geometric construction. First you draw the circle of 80 mm diameter with center O. Then draw OA as radius of the circle. Then taking center A, you draw one arc passing from the center O, which will intersect the circle at point B and C. You join point B and C, so you will get the intersecting point with radius OA, the point D. Then BD, size of the BD will be the length of heptagon. So once we are knowing the size of the heptagon, which is equal to length of BD, you get the 7 successive point on the periphery, and you will get the required heptagon on the circumference of the circle which is inscribed in the given circle. So here BD is the length of heptagon of the side. Once by geometrical construction we can find out the length of the polygon, then we can draw the polygon on the periphery of the circle. This is again the special method of octagon inscribed in circle. Here also we are not knowing the length of the side of the octagon. Here we are knowing the size of the circle, means diameter or radius of the circles. So first of all you draw the circle having the given diameter, and you draw horizontal diameter AB, then vertical diameter CD. Then you divide this angle AOC by bisecting this right angle, and again you bisect COB angle, then you will get the another bisector HG. So we have got two bisector line, HG and EF. So in this way, first of all we have find out 4 vertices by drawing 2 diameter, horizontal and vertical diameter. Then we have bisected this right angle triangle, so we have got 8 points on the circumference: A, G, D, F, B, H, C and E. You join all these points successively, then we can get the octagon which is inscribed in this circle. So here we have used the geometrical constructions of the angle, how to bisect the given right angle. And with this help of these geometrical constructions, we have divided the circle into 8 parts. Each angle, included angle, is 45 degree, and we have drawn the octagon. First we have drawn 4 vertices, so each angle will be 90 degree. Then again we have bisected this 90 degree angle, so we have got the 8 vertices and each angle is 45 degree. This session we have drawn the polygon. In polygon we have included triangle, square, then also pentagon, hexagon, heptagon and octagon. In first method we have drawn the special method and general method when we are knowing the side of the polygon. In second alternate method we have drawn the special method and general method when we are knowing the size of the circle, means diameter or radius of the circle. So in this way, by general and special method, in general method we can draw any polygon, and in special method, particular method, we can draw the special type of polygon in which this method is included. So in this way we can draw the triangle, square, pentagon, hexagon, heptagon and octagon. Friends, now you can draw the line, circle, arc, polygon, and combination of these different drawing entities which will satisfy the given constraints, different constraints. So this geometrical construction is the heart of the engineering drawing. If you are knowing all these methods of construction, then you can draw any complicated drawing representing any object or product, and you can prepare the drawing. I hope that this practice will be enough to draw this drawing in AutoCAD also. Once you are knowing the theme, principles of geometrical constructions for drawing the different polygon, arc, circle, angle, then you can use also AutoCAD. And with the help of computer and software, you can use AutoCAD also, and you can produce any drawing, assembly drawing or detail drawing, with the help of this AutoCAD. 3D modeling, you can use 3D modeling, and you can prepare assembly drawing, detail drawing, that is called production drawing, and you can got also orthographic drawing by drawing this 3D modeling. So this is the real application for drawing, engineering drawing. Thank you very much. Thank you to all of you.